In the last workshop, I was demonstrating how we use formulas to build prompts and how those prompts can then parse the result of the AI and put together the next prompt. And so, prompt by prompt, step by step, you can build an agent that works its way through a process. And one of the things I mentioned was that when we're translating text from one language to another in the insurance industry, originally it was making a bit of a mess of the translation of specific technical terminology. And so we found that we needed to include a document, a glossary that said, here's the terminology that you should be looking out for in one language. And then in these square brackets, here's how you're going to translate it into English so that our English translation preserves the technical meaning of some of the terminology, because without this, it was inclined to do its best, but not quite pick up on the terminology. And so this document that contains this information, this is the one for Italian, is part of what we call the knowledge base. And it augments our AI steps by providing highly specific knowledge that is limited to just our particular use case. So it's not to be found on the internet. It's not part of the normal training of the model. And this is the simplest case of using a knowledge base where the formula that builds the prompt knows which language we're using. And therefore, it is able to select the right page. So if it knows that the message it's dealing with is in Italian, it will pick this page and say, let's add this page to the prompt into the context so that the AI knows how to translate Italian. There would be a similar page for German and French and Spanish and any other languages you're using. This type of knowledge base is often called semantic injection. We're injecting the right knowledge into the prompt using our orchestration formulas. However, there are times when you need access to a much larger knowledge base, and it won't easily allow you to simply do that trick. And so here I have a demo where I'm going to ask the AI to code a Coda pack for me. I want a formula called hi that has two parameters, name and company, and it is to return a schema object with those two values. And it's a straightforward prompt. I send it off to the Coda AI, and it doesn't work. And the reason it doesn't work, I mean, it's doing better this time. It said, let's create a formula and so on. And that's because the AI that I'm using, the Coda AI in this case, but it would be the same for Notion and Excel and others, it doesn't have access to the knowledge base of how to do things in Coda. To gain access to that, I have to go to this website. By the way, I'm checking now to see if you guys are seeing my screen. I should have checked this earlier. You can see the screen I'm sharing?
Yes, it's fine.
Okay, thanks. So here's the Coda Pack software development kit that you need to ingest if you want to know about creating packs, right? And so there are guides, and within the guides, there are pieces about how to add formulas, how to do authentication. I mean, this is a sizable chunk of information in a large, well-structured, but rather complicated website. And you need to know all of this if you're going to do things in Coda. And if you're being asked to do things with the Coda API, then you'll also need the knowledge that's contained here, which is the Coda API documentation. And it says that if you want to create a document, here's what you do. If you want to create pages in a document, then if you want to get information about a document and so on. So there's a vast amount of information here that I would like the AI to know about, and it doesn't. And then when it comes to writing Coda formulas, there's another body of knowledge here that I want, this document, which contains all the information about how to write formulas in Coda. So ideally, I would like to add all of this knowledge to my Coda document so that when I ask it to do something simple like this, it will actually be able to generate the correct result. And so the way I'm doing that is I have pulled together what they call in AI a corpus, a body of knowledge. It contains a set of documents, 10 documents, and these documents contain all of the stuff that I've just shown you, right? So there's the documentation for building Coda packs. There's one document here about how to use the formula language. So if I take one of these, for example, the one for doing sync tables, and open it up here, you'll see that if I go down a bit, sorry, here's the document that's all about how to add sync tables to a pack, right? And it's big, it's long, it's complicated. And what I've done is I've literally scraped this from the web and put it into a Coda document as a page inside a table. So it's a Canvas column, which is how you fit pages into Coda documents. And it's got a large amount of information in there. The problem is that that's too much information to be able to put all of these into my prompt all at once. If we look down here, all of the data that I've pulled in, all of these documents, adds up to 618 kilobytes. And that's too big to be trying to hand over all in one go in a single prompt. So what I want to do is to have a two-step process where, first of all, I give it a query and it figures out which of these documents contains the information I'm looking for. And then a second query will pull in that document and use that to solve the problem. And this technique is known as the recursive abstractive tree-oriented retrieval, or just Raptor. It's recursive because I'm going down through the tree, summarizing what's in there, and then I'm abstracting from the tree the particular pieces of knowledge that I want. And that's the essence of what I want to show you guys how to do in this workshop. So if we go and look at some queries, and if I go back and look at the original query that I started, which is create a Coda pack for a formula called H1 that has two parameters, and I now tell it to go and do that, it will do two steps. The first step is it figured out that I need to go to the Coda Packs SDK to get the information. And then in the second step, it has actually found all the information it needed and has created a correct Coda pack. So I've used a two-step process. The first one is look at this, look at the summary of the information and pick the document that makes the most sense. And it picked this document and then use that document to answer the question. So here I have another query, which is create a formula that will add a row to the orders table with a product set to the text that's in my order. The quantity is set to the sum of the numbers that are in the quantity list, and the amount is set to the resulting quantity times the value of the price in the table prod. So I'm giving it quite a complicated prompt, and I'm saying, go build a formula that implements that. So it has figured out that, well, that's in the Coda formula language document. And so this is what the formula should look like. I want to add a row to the orders table where the product is set to my order. The quantity is set to the sum of the quantity list, and the amount is set to the sum of the quantity list multiplied by the price for the product, where the product ID is equal to what's in my order. So quite a complicated query, and it has produced the correct formula. Here I'm saying write a Python code that will use the API to create a new row in the customer's document on the orders table where the product is set to this and the quantity is set to 45. So let's ask it to do that. So it wasn't able to do any of these things before, but now because I have a two-step process built in, it's able to go and solve the problem. So here it has said you import the API requests, you then have to set up the data JSON, and then you need to do a response is equal to a post where I use this URL, which is up here. It has figured out the right URL. It has figured out the right authentication. And it knows how to do the headers. It has built the JSON for the data. And then it can check the response, and it knows it's looking for a response of 202. And if it doesn't get a response of 202, then it should print an error. So all of that knowledge is contained in this corpus, these 10 documents. But I can't load all 10 documents in at once. So instead, I use this two-step process where I take the full document and I build a tree structure that summarizes each of those documents. So if we look at the sync table one, and if I open the so here is a summary of what's in the sync document in the form of a tree. This syntax is called YAML. It's equivalent to JSON, but it's a bit simpler. It's easier for humans to read, and it's actually easier for the AI to process as well, because JSON has a lot of squiggly brackets and quotation marks and prompts and so on. So one of the steps I do when I'm building my knowledge base is I run a prompt that says, summarize the document below, listing the topics and subtopics to 4 levels deep. And there's a system prompt that also says, always output in YAML format. And so I run this whenever the data model changes, and it will build a table definition of what's in the document. And I do that for all of the documents. So all of these documents have the knowledge base, which is a full document, and they're quite big. And then a tree structure, which is the summary, and the trees are quite small. And that means I can take all of the trees and put them together into a single top-level structure, which is a summary of everything that's in my knowledge base, but only a summary down to a certain level. And so later we'll go through the formulas and the prompts that make all of this work. But what I'm trying to get to is a situation where my agent has access to a vast amount of knowledge, but it only brings in the one tiny piece that it needs to work with at any time. The biggest single chunk that I bring in is 122 kilobytes. And that fits quite comfortably into the AI, and it's able to understand it. So that's the demo that I want to take apart and rebuild. Before I go ahead and go to the next section of my presentation, which is to get into the how it works access, I'm going to pause quickly and see if there's any questions.
Yes, so let me use the opportunity. Is there any need for a specific AI to be used to convert this, or the most basic, cheap one can do it in a proper way?
I'm using the AI that's inside the tool that I'm using. The no-code tool I'm using for this is Notion. Is Coda. If I was
Coda.
using Notion, I would simply use the AI tool that's inside Notion. If I was using Airtable, I would use the default no-code tool that's in Airtable. And because I'm using Coda, I'm using the default no code that's inside Coda. So I'm not
Okay.
going outside and going to any other tool or talking to any other application. I'm literally
Mhm.
doing all of this inside Coda using whatever AI tool Coda happens to be using. And right now it's using GPT 4.3 something. It's using
Okay.
the GPT-4 model stack at the moment.
Mhm. Thank you.
Yeah, so it's all basic and simple. My goal is to make this available to people who only know how to use formulas and prompts inside whatever their no code tool is, and they don't have to go outside and do anything extra. Okay.
Yeah. Great.
Anything else? Right. So now I'm going to start to go into a little bit more detail about why we have to go through a slightly more convoluted process in order to make this work. And so I'm going to do one of my famous squiggly diagrams. And I'm going to start with the diagram that shows what I call the pyramid of data that you have to deal with in an AI. So when you're doing anything in AI, everything has to fit into this piece of memory called the context. So your prompts, your data that you're providing as part of your prompts, any knowledge that you're putting in there, they all have to fit into this small little piece of memory known as the context. And it also has to have room for the results. And this piece of memory
Max, sorry
is,
to interrupt.
yeah.
Could you make your screen bigger and ours more to the side, let's say?
Oh, let's see if I can do that. Okay, yeah.
And maybe if you can mirror also, so because we see now, I don't know if it's possible with mirror,
Oh,
because
you're seeing it in mirrored. Okay, well,
yeah,
I can try and change that now. Let me see. So
yes,
thank you for pointing that out. Because
yeah.
I'm operating on a single screen here, I actually can't tell
No, no,
precisely
no
what's wrong.
worries. Okay,
Yeah, it looks
go.
mirrored for me now, but I need to go back.
Doesn't
Okay.
matter.
Okay. So your prompt, your data, your knowledge, and your response all has to fit into this block of memory called the context. And it's roughly, in terms of the amount of text you can fit in, it's about a megabyte, right? I mean, it actually contains a lot of tokens, but in terms of text, it's about 1 megabyte. You can think of the context as being like a spreadsheet that has one row for every token, roughly row for every word. So that means for most models, it's about 128,000 rows. And each row then contains all of the floating point numbers that make up the token. And there's 1.5 thousand columns. So your context window is fixed at this size of floating point numbers. And that will take roughly a megabyte of text to fill it up. And by the way, every time you add something new, it goes in at the bottom and it shoves everything upwards. So after a while, your context doesn't overflow and generate an error. It just forgets whatever's at the top, which is fine if you're having a conversation, but can be a problem when we're doing lots of knowledge based work. So we have to be aware of the fact that you've only got a very limited amount of information available to you in your context. The other source of information we have when we're building agents is, and I showed this at the last workshop, is you have your database tables. And you use your prompting formulas to take the content, take items from your database and literally put them into the context. So the formula that creates the prompt is pulling in information from your database tables, either your Coda tables or your Notion tables or your tables from Airtable. Or if you're using Excel, you can do the same thing with tables in Excel. And roughly speaking, when we're building these tables inside no code tools, we're talking about 125 megabytes. If you build more than 125 megabytes of tables inside your no code tools, then you're probably pushing it a bit far. So we have a database of about 125 megabytes, but we're only pushing a small amount of it into the context for every single prompt that we execute. And then the next piece of knowledge that is there is the actual large language model itself. And the large language model takes up about 4 terabytes of data on the servers that it's running on. They split it up into multiple chunks or parts of that called a mixture of experts, but in total, it's about 4 terabytes of data running on the server. It contains 1.8 trillion parameters. And it's been trained on a large part of the internet. And so this is the bit that understands English and German and all the different languages, and it knows a vast amount of information. However, it's like a professor from college who's been in a coma for 6 months because it doesn't know anything since it's been trained. And it was trained maybe 6 months ago. So it doesn't know anything about the current state of the world. It doesn't know anything about what's on the internet. Now, the next piece of information that agents have access to is much bigger. And this is where large corporations build a knowledge base for themselves. They take all their documents that they need and they load them up into a knowledge base. It's stored as a vector database. And the companies I'm dealing with are loading up about 10 terabytes of documents. They're going back over a gazillion emails and minutes from meetings and documents about policies and procedures and all of that kind of thing. Generally speaking, it's a storage that has about 1 million what are known as chunks, blocks of data, where each chunk is less than one, it would be in the order of 500 words. So in order to use this, you've got to take your documents, shred them up into chunks of about 500 words, and process each chunk to produce what's known as a vector. And each vector contains the text, what is called metadata, which says where this data came from, the name of the document, which page of the document, which paragraph in the document, and then about 1,500 tokens or parameters. And these 1,500 parameters are very similar to the kind of tokens you have inside your context. They describe the meaning of that chunk. And so in a large corporation where I want to search for what is our policy and our procedure for doing a return from a refund to a customer who has returned a product, it will take the query and it will then run it through this vector database and do a very quick search. But it's not searching for text, it's comparing these 1,500 parameters for each of the chunks. So within a matter of seconds, it'll come up with the top 5 matches, the top 5 pieces of data that seems to match what you're asking about, and those will be shoved into your context. Because obviously you can't fit the whole knowledge base into your context. And this process is known as retrieval augmented generative AI, or RAG. And you've probably heard and seen something about RAG, and this is how RAG works. This is the big industrial strength RAG. But to do this, you have to go outside your no code environment and you have to start dealing with a product that does vector databases. Pinecone is the one that most people are using, but there are others. So the Pinecone database. And it's a big, expensive process to take all of your documents and put them through this process. And there's a lot of technical decisions you have to make. What sort of chunking policy are we going to use? What kind of metadata are we going to store? What sort of search algorithm are we going to use? There's several different search algorithms. But when people talk about RAG on the big industrial scale, this is what they're talking about, where you would have 10 terabytes of corporate data for a big corporation being pulled in when they're needed into your tiny, tiny little context up at the top. And then the other piece of the world that your AI often has access to is the internet. And this is where we add a search capability to the AI, and that allows you to go to the searchable web. And the searchable web is estimated to be about 38 billion pages, which makes it in the order of 100 petabytes, which is a big number that I don't know how to write any better than its gazillions. So the size of these boxes represent the size, roughly, not to scale, of the information, and how high up they are represents how fast the AI is able to access them. So everything that's in the context is available instantly. Everything that's available in the database, I bring in when I need it using the formula that generates my prompt. If I'm accessing a knowledge base, then I will use the RAG tool to pull in, to do a search, find the chunks that match, and bring them in. And then finally, if I need to do a search on the web, there's a web search tool available that will then find the matches on the web and then bring those matches in to the context. And then the AI will continue to do what it does, and that is process that information that's in the context and summarize it and make it available to you. Now, all of this is to give you some idea of the kind of scale and relative size of these different parts of an AI system, so that when we're building agents that we want to run very fast and very accurate, we actually are probably not going to be interested in using the RAG system. And the reason for that is because, first of all, that requires you to go outside of the no-code tool, and you probably need to get the help of an AI expert, or you need to go to an outside product to do this. So in the agents that I'm building for my clients, I don't actually use the RAG process. Instead, I put the pages that contain the information I want inside my database, and I bring them in as needed into the context. And this gives me a much more controlled, deterministic process. This one is probabilistic in that it goes through and does its best to match based on the meaning. It also means that every time your knowledge base changes, you have to reload your database with those changes. With this process, I can simply bring in the pages of documents that I want when I want them, and it operates a lot more simply. So I'm just going to pause for a minute and see if there's any questions around that. Okay.
I think you answered already my questions which came up.
Okay, that's good. Right, so let me switch back then to So now I want to go and take a look at how I am building the equivalent of RAG, but entirely inside a no-code tool like Coda or Notion. And for that, I'm going to go to the demo that I did earlier. I'm just going to take a moment to go and look at the experience I've had. So as I said before, when I first started looking at AI, and I only did it reluctantly because my clients were saying, oh, we need to be able to do AI. My first experience was that it was unreliable. This whole thing of doing prompt engineering was just not deterministic. I came from a world of using formulas, and now suddenly we're doing these vague, verbose prompts, and we're sometimes getting hallucinations, and you're not always getting back what you wanted. So it took a lot of effort to figure out how to make these things work. So the first step was my last workshop, where I broke everything down into steps, and each step is so simple that it's a tiny prompt, includes information from our database tables, and only does one thing. And that was so much more successful. There was less opportunity for errors, for the AI to get confused and lost in complicated prompts, and there was no hallucinations because you're forcing everything down to such a simple level. The next thing then is to start bringing in documents. And the first thing we discovered is that the kind of documents that most people have don't do very well, no matter how you try to bring them into your prompt. So, for example, spreadsheets that contain numbers are very poor. They don't do well because the large language models don't understand numbers. And so when we're doing large spreadsheets, we use a different technique where we build a separate AI machine learning model to handle the numbers side of things. Obviously, if you've scanned in paper documents, the AI doesn't do well with that, and you have to go through a complicated process to convert those scans into pure text. And you lose something along the way. So scanned documents proved not to be very useful. Surprisingly enough, PDFs proved not to be terribly useful because the PDF standard defines precisely how the characters are to be printed on the page, but it doesn't actually understand paragraphs, lists, headers, subheaders, all that kind of thing. That's somewhat hidden from the system when it looks at a PDF. Now, there is a startup that are working on turning PDFs back into rich text that will allow us to start using PDFs again. But for now, whenever somebody gives me a PDF, I say, can you point me at the source? Because what I really need is to get to the document that generated the PDF, because AI does not handle PDFs very well at all. Somewhat the same for PowerPoint. When the PDF looks, sorry, when an AI looks inside a PowerPoint, it's not really able to get the full understanding of the tree of information that's in there. HTML is very good. The problem with HTML, though, is that it's very verbose. All the HTML tags so if you scrape things off the web and don't tidy them up, you get a lot of noise in there as well as the content. Documents from Microsoft Word or from Google Docs work very well. AI is well able to understand what's in there. However, there's a lot of formatting information that clutters things up, and so it's not a very efficient use of your limited token space, but it will work. A simplified version is the RTF format, which is rich text format, and that's much better. So if you can turn your documents into RTF, they perform way better. Then we start to get into the more specialized ways of representing knowledge. JSON is very good because it's highly structured. You can represent a knowledge graph or a knowledge tree with extreme precision in JSON. The problem is it does consume a lot of tokens because there's lots and lots of extra squiggly stuff. And sometimes the AI can get a little bit lost inside JSON and that it loses track of the open parentheses and the square brackets and stuff like that. Documents that are written in Markdown are among the best. And that's because the AIs have seen a vast amount of Markdown formatted documents and it understands Markdown extremely well. And Markdown can include tables as well as structured lists and sublists and paragraphs and headings and subheadings and so on. And then the best one of all, the one that performs the best in our experience, is this format called YAML, which is yet another markup language. It's as if you took JSON and stripped out all of the squiggly brackets and commas and quotes and colons and came up with a much better, simpler format. It's human readable, but it's as specific and precise in its structure as JSON. And so YAML is the format that I always ask the AI to output in. And I use YAML a lot in putting together knowledge bases and particularly summaries of things. In terms of the kind of documents you want to put in, again, when you start talking to clients about what sort of knowledge information have you got, the worst type is this stuff down at the bottom here, where you're looking at meeting notes and transcripts of meetings, legal contracts, which are very confusing to the AI because there's a lot of, they're very precise, but it's not the normal language. Emails, messages contain a lot of noise and narrative, and it's not so easy for it to extract the nuggets of information that are hidden within it. Marketing materials and sales materials have a purpose. They're trying to sell things, so they're very overburdened with description and making everything sound better than it really is. Informal communications, and in particular journalism, these contain the knowledge that you want, but it doesn't make it easy for the AI to pull it out. So when people are presenting these types of information, we normally want to put a bit of effort into extracting the nuggets of information out of them and curating that manually to produce the best type of knowledge that we use. And so you'll often find that we spend a lot of time editing this stuff down or running an AI over it to say, take a look at all of these meeting notes for the 50 meetings we've had for the last year and extract the actions, extract the decisions, extract the nuggets of information and put those into a YAML format. And that's way better, much more useful when it comes to doing knowledge work in AI. Almost perfect, but not quite, is knowledge that has been already digested and structured for maximum impact. So wikis, things like glossaries and user guides, checklists, all the training documents that you have for teaching people how to do things. These do very well. They're not perfect, but they are certainly far better for doing knowledge work with AI than anything that's down here. And the best of all is when you get into this space where you actually have well formatted and structured knowledge graphs, technical documentations, procedure definitions that are quite specific. So if we go to the documentation that we're seeing being used in my demo, this is highly structured. The Coda API is extremely structured. When you extract the contents of this into a markdown structure, it's very easy for the AI to use. And somebody recently posted a version of this that was done in markdown, but it really was almost like YAML in how structured it was. And I scraped it and used a scraping tool to get it into a markdown format. And similarly, the formulas documentation is highly structured. This does very well. The AI is able to digest all of this and understand it and use it to answer questions. So when it comes to building your own tree of knowledge inside your agent, you want to go as far up this line as you can towards Markdown and YAML. And you want to go as far up this type of document type to get up into technical documents, procedural definitions, knowledge graphs, or at the very least, highly structured documents like wikis, guides, checklists, and training docs. So our goal with building these knowledge bases, whether you're using RAG or whether you're using the injection process that I use, you still want to get as high quality a knowledge base as you can by moving up the scale in both of these directions. Any questions?
Yes. How are
Go
you
ahead.
convincing your customers to spend time on that?
Yes.
You prepare
The
them in
results
advance.
are so much better when they do. So, yes, they find it well worth it, right? Also, if we go back to what I said in the last workshop, the type of people I'm dealing with are people who know the standard operating procedures very well. So they've already been producing these documents for years, right? Um, they know how to do structured tables in databases, and they have the ability to produce very, very good technical documentation. So I'm dealing with people who are very well versed in this world.
Mhm.
So they
Yes.
actually find it very useful. And I don't have to sell them hard on, look, if you hand us over a bunch of this stuff, it's not going to do as well because there's a lot of noise and it's not as well structured as it could be. Either you've already invested time and energy and effort in having a very good set of documentation. If you're ISO 9000, you've got all of this. If you're in a regulated industry, you've got all of this. If you're being audited on a regular basis, then the stuff that really matters is probably up here in this sort of space anyway,
Yeah.
right? And then which format you put it in is, if you've got documents and they're Word documents, you can easily churn your Word documents into Markdown. And that's
Mhm.
usually good enough. This is the sweet spot here. Obviously, it takes more effort to get to YAML, but if you have Markdown, that's good. But you can go from Markdown to YAML using an AI prompt. So we've never had any problem with that. Okay. Any other questions?
Thank you.
Okay. So with the particular demo that I'm about to take you through the building of, we have a knowledge tree that looks like this, right? At the top level, we have a series of documents about different topics. And we
Sorry, but
know,
we don't, we only see you.
oh,
So there is no, we don't see any
sharing
sample.
my screen. I'm sorry. Let me go and fix that. So share my window. And okay, now do you see the document that I was talking about, the graph?
No,
No, you don't.
unfortunately not. No.
I see. You have to click an extra button that I wasn't aware of.
Yes, now
Oh,
it's
well.
available.
Okay. So what I'm saying is that you have these formats, and the ones at the bottom are really bad. The ones in the middle are pretty good, and the ones at the top are where ideally you'd like to go. And the types of document content, the stuff down at the bottom here, messages, emails, marketing and sales stuff, journalism scraped from the press and magazines, not so good. This stuff in the middle, very good, wikis and glossaries and guides and checklists and your training documents. But the best is where you handcraft knowledge graphs, or you've been producing technical documents that are very specific, or procedure definitions, guides, and so on. These are the best. So what I was saying is, when I go and look at the information about how to build a pack, this is highly structured. This is technical documentation of the highest quality. This is even higher quality in that it's actually a much more structured system. It uses the same pattern over and over again for each of the different APIs. And the document that we use for Coda formulas is also highly structured, because for every formula, it gives a breakdown of what the inputs are, what the outputs are, and a description of what it does. So this is all the very best top quality type of knowledge that you want to put into your knowledge graph. Okay.
Can you share what tool you use to convert it to Markdown YAML?
Um, I think I just use the browser. I think when you're in a document, you can extract.
Uh-huh. Okay. Yeah.
It's a good
Because
question, because maybe I did. Okay, I do have a series of tools that are good for scraping from the web. I just can't remember off the top of my head which one I use, but there are scraping tools.
for in next session, maybe you can pay
Yeah,
attention.
or else I'll put a note in once I have remembered it. It's just my mind is pretty blank at the moment. Yeah,
Don't
sorry
worry.
about that.
Sorry to interrupt. Sorry.
Yep, yep. But obviously, I went through each of these pages or each of these websites, and I scraped them into documents. And then I loaded those documents into a table in Coda so that I could manipulate them. And I broke them down into these. And the reason I broke them down, because quite a lot of these originally ended up on one file, is that the size of these has to be under 128K if I'm going to bring it in and use it in a prompt. If it's bigger than 128K, it doesn't work so well. So I basically took all the knowledge to do with how to do things in Coda, from how to build pack formulas, how to do API specifications, all the different data types and parameters in pack building, and I split it up into chunks or pages. Each page is these topics, and it fits into 128K. And then I ran an AI prompt, which I'll show you in a moment, to take all of the stuff that's in this, right, and say, take all of this and summarize it at the top level. So I produce a summary at the top level for all of the data that's in here, right? So I say, produce a summary, and I produce the summary in YAML. And that is the top level. Sorry, that's the second level. And then I take all of these summaries and I compact them to concatenate them together and produce an overall summary for the whole body of knowledge. I'll show you that in a moment. So the first step is to look at this and say, which of these pages of information is likely to contain the answer to the question you've given me? And it says, you're building a sync table. This is the one to go for. And the second step then is to say, okay, load this document into the prompt as the knowledge that you're going to use, and use that to generate the answer. And this two-step process is what allows me to access this huge amount of knowledge inside a tiny, tiny, tiny little context window. And we'll see how I do that now if I go to my demonstration. So down here we have the knowledge tree, which is generated by a formula. And that formula is simply take the tree structure from all of these documents and concatenate it into one blob, right? So the top level tree is just squish together all of the smaller trees. And you can use that then to see which piece of information we're going to look for in order to solve the problem. The tree structure is generated using a prompt, right? It already has a system instruction to always produce YAML. And it simply says, summarize the document below, listing all of the main and subtopics to 4 levels deep. And as I said, it defaults to always using YAML. And this is what it produces. It goes through the whole document and says, here are the items that are coming up. And this means that when the AI does its first step, which is to look at the knowledge tree and figure out which document has the information I want, it will find somewhere in here something that says, this is the information that I'm looking for. Therefore, the document I need to load is the ACT automations and action button extensions to Coda. And we'll see the prompt that does that in a moment. And then the second step is, once it has decided which document it wants to look at, it will then go and load up the correct document and put that into the prompt, right? And so you see this fairly large amount of text gets loaded into the prompt. And although it's in a nicely formatted document here, when it's put into the prompt, it ends up in Markdown. The Coda AI system always converts everything to Markdown if it's a structured document. So I start off with a corpus of 600, around 620 kilobytes. But my first query only looks at a tree structure of 22 kilobytes. And at any one time, it then only loads one of these. And so the largest one that's loaded is 121 kilobytes, 122K. So all of this fits very nicely into the context window of GPT-4. I have to say, I got the impression when I went looking at each of these documents that this was a huge amount, a really, really vast amount of knowledge. But it turns out that when you bring it in and stick it into a single structure, it was less than a megabyte. It's quite surprising, but there you go. And this is something I've noticed, that whenever we try to solve a particular problem, how do we handle claims against insurance policies? Let's bring in all of the procedures, all of the documentation, all of the guidance and checklists. And you're thinking, oh, that's going to be many, many megabytes. Turns out, no, it's usually only 1 or 2 megabytes. And then we start to break it down into a knowledge tree. And that then allows us to create an agent that's able to manage this. So now let's look at the actual prompts that are used. So let me take the one here at the end, which is create a Coda pack with the following details, right? So when I execute that, it will run this button. And it says, first of all, refresh the assistant for the topic. In other words, do the AI for topic and then do the AI for the results. So it's a two-step process. So what's the AI prompt for each of those? Well, the AI prompt for the topic is to simply say, here's the description of the entire corpus, which is all of this, and it goes through it and say which of the items listed below will most likely provide the information needed to solve this problem. And the problem is what's in the prompt column, which is this one here. It will come back with the name of the document that contains the information. So SDK is the one it came back with here. CFL is the one it came back with here. API is the one it came back with here. So now the second step is a simple piece of AI that says, here's your prompt, right? Which is create a formula, blah, 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 using only the documentation below and respond with a code block format. And then it is pulling out the topic from the knowledge base that was selected. And so this is how this two-step process works. I've loaded all my information into my corpus. I have used AI to produce a summary in a tree structure. And then I use two steps. One is of all of the tree structures, which one contains the information I'm looking for? And then the second one is, okay, using that document here, solve the problem. And this is known in the business as Raptor, which is, yeah, a mouthful. But basically, it's the poor man's version of RAG that doesn't involve going outside. So I'll pause for a moment and see if there's any questions, or have I lost you all in the dust?
No, I think it's very clear explanation.
Okay. Now, having developed this very effective, somewhat simple, but let's face it, not entirely super simple way of doing it, we've actually found over the last 12 months that we don't end up doing this very often, right? And the reason for that is that if I go back to my first workshop here, here's the simple broker, where it's taking information from a message queue and sending it to a translator. Most of the times, the formula that builds the prompt to do the translation knows enough information to choose the correct body of knowledge. So in this case, I don't need a complicated process to figure out. I have one prompt that says, what language is this? And a second prompt that says, it's Italian. Translate this to English using the Italian terminology glossary. So I didn't need to go through a complicated tree structure to do that. So sometimes you need to use a tree structure of your knowledge, and this is a way to do that without having to go out to a vector database. But very often, because of the way we're building our agents to do one step at a time, and each step is very, very simple, we find that we usually know which piece of knowledge we need to include in the prompt at any step along the way. So I think it's fair to say that there's a spectrum of knowledge base RAG activity. On the advanced side, you've got the full-blown vector database. And on the simple side, you have a simple where you already know I'm looking for the Italian page from the document, just use that. And then between the two, we've got this Raptor approach where I have lots of documents in a table and I summarize it in a tree structure. And so I have a two-step process where it first of all says, which document do I need to go to find the answer? And then pull that document in and use that to solve the problem. So that is the meat of what it was I wanted to cover in this workshop. So I will stop sharing my screen and go back to where I can talk human to human, mano a mano, and say, is this useful? Is it something you could ever see yourself being able to do? Or do I need to invest more energy and effort in making it even simpler and easier for people to understand? And JP, I would say you're pretty much a prototypical example of the kind of business manager I'm aiming at. Whereas Stefan, I think you probably are a little bit more advanced and probably would be able to go and use a vector database if that's what you decided to do.
For vector database, I will not be able to do myself, obviously, because I don't have background in that area. What you showed is for sure possible for me to do.
Yeah, yeah. Particularly if I hand out templates for this, which is something I'm working on, so that you'll start with a template and then be able to put in the bits that you need.
Not just, yeah. Of course, there are certain things what I think about, but they are not so much with building. And you already replied, you are lucky that you end up with a regulated business like in the insurance industry.
Yeah,
You are also right that with businesses which have ISO certification are already also in that direction.
yeah.
But unfortunately, and you know yourself very well, in Greece, Bulgaria, the ISO standard is not.
It's not very common. So it may be that you have to, if you're working inside your own organization or you're selling your services to an external organization, it may be that you need to put them through the process of building a proper knowledge base. And
Exactly.
that can sometimes be a hard sell because OpenAI, Grok, Perplexity, they're not giving this message. They're saying, oh, just point us at your website and we'll pull everything in and we'll make it all happen. But the reality is that you do have to invest in knowledge management. It is something you have to do if you want AI to be highly effective. Now, you can use AI to help you do it, but you've got to have a good knowledge base if you're going to do this. Otherwise, you're going to be stuck in the other end of the AI swimming pool, which I call the personal productivity, where all you're able to do is automate tasks that you do as an individual or individual managers do. And you're not automating standard business operating procedures where you have an AI agent that's actually able to move product from place to place, to move
Yeah,
funds from one account to another, and actually do things in the business that up to now humans have been doing. So, yeah,
I think
that is a challenge.
I, I think it's a good point and a good line you draw from personal automatization to company
Yes,
automatization.
yes, yeah, absolutely. And with that, we've just lost JP. Stefan, I don't know, are you in a position to
Yes, hi.
turn on your microphone and give me some feedback on how well this is coming across? Do I need to do more explanation work on it, or what is it that gets us to the next stage?
Do you hear me?
I hear you. Yes, indeed.
Okay, for me, everything is clear, but I have two questions. First, I see that your knowledge base contains images. Does Coda AI handle these images well?
No, no, and the new Superhuman Go, what used to be known as Coda Brain, the new Superhuman Go agent that we'll be able to build when it's released, ignores images, right? You give it a document containing images, it will include any of the text, the alt text for the image, if it's there. And if not, it will just not include the image. It will only include the text. And
Okay.
by default, it uses Markdown. If you give it a richly formatted text, which is what I'm doing in most cases, it's automatically converted on the fly into Markdown when it goes over to the AI. So the Coda AI, it's also true for the AI for the other tools as well, works in Markdown by default and doesn't include the image. It does include the alt text for the image. And sometimes documents are very good at giving an alt text that explains the image extremely well, and therefore you get useful information from it. But very often it doesn't, and therefore you just don't get it.
Okay. And the second question, um, I know that in Coda you could use on relation columns, you could use auto select, AI auto select.
Yes.
Have you tested this, or do you
I
think
have,
it's
yes, I
for
have
this
tested it,
purpose?
and there are some tricks, and I'm going to one of the workshops is going to be on a subject I call precision AI, which is the tricks I use to move away from probabilistic AI inferences to deterministic AI inferences. And one of those tricks is, as much as possible, to use the AI select process that you are talking about. So I can
Yeah.
say, use this prompt to select one of the 15 document types or one of the 10 different statuses and so on from this table. It works if the description column of the table contains enough information to make the prompt useful. But if the description column of your table just contains one word or a 3-letter abbreviation, then it's not really going to work very well. So it turns out that it matters what the description are. One of the columns is the description column for the table.
Okay.
The information column, and it really matters which one. So what I always do is I have a formula that combines the 3-letter code for the status with a full sentence explaining what that status is, and make that formula the descriptor, the information column for the table. And then the Coda AI system that you're talking about works extremely well because it's got enough information coming into the prompt for it to be able to rationalize or infer the correct one. So if you use it by default, it won't work. If you know this trick and you start to give it more information in the descriptor of the rows, then it will work.
Okay.
And it
That's
works
really
extremely
interesting.
well. It works extremely well. And it always helps to have a default at the bottom, which is not available or not known or some error at the end so that it only picks one of these rows. And it will always just be constrained to pick one of those rows. And that reduces hallucinations and errors and everything else. So it does work very well, just they don't explain it very well, and you have to know that trick.
Okay, thank you.
Okay. Stefan, am I right in thinking that if you had to go and build yourself a vector database, you would figure a way to do that? Or am
Yeah,
I
I tried that,
okay?
but I end up with not enough good
Results.
informations
Yeah,
for the knowledge
yeah,
bases.
yeah. It's very probabilistic. I don't mean to knock it because the whole industry is using it, and I'm seen as a bit of a contrarian for not using it. But it's very probabilistic. You're shredding your documents into small chunks, and whether a chunk contains enough information for it to be able to really figure out what you're looking for depends on how dense the information is in your documents and what chunk size you choose and how much of an overlap, because sometimes the sentence that's important gets shredded between two chunks. And then there's the whole algorithm that's used for doing the search and so on. I have much more control over how my knowledge base works using this technique. And for now, I'm very happy to do that. And my clients love it because they know how to write formulas, they know how to write prompts, and they know how to handle tables. They're self sufficient. My clients don't like to have to go to the IT department and say, please, can we have a developer, or please, can we have a database expert, or please, can we have permission to do this, that, and the other? Because it's very expensive and takes a long time, and they much prefer to be self sufficient.
Yeah, yeah. And for me, another issue is that I mainly use Czech language, and these vector databases uses some transcriptors that are not really well
Yes.
working
Yeah.
with
Yeah.
Czech
Yeah.
language, so
Yeah. Yeah.
it hallucinates.
I
Very
have a project where they use the Belgian language, And I found that it was necessary to do a translation exercise to get the knowledge base into English. And the reason is because the volume of Belgian training data that these models have been exposed to is way smaller than the volume of English training data that they've been given. So, not surprisingly, they're very good at English, they're not as good at Belgian. I imagine that the same is true of the Czech language. I'm in Greece, so I have a lot of documents that are using the Greek alphabet. And AI, large language models, are really not very good at handling alphabets other than the Latin alphabet for a start.
Yeah.
The tokenizers work far better for Latin alphabets than they do for Cyrillic or Greek alphabets. And then they haven't been exposed to much in the way of test or training data from these non-English languages. So you may still have a problem, but certainly you have much more control over it if you're building your own knowledge base in this way.
Yeah. Okay. Thank you.
Okay. So, guys, if there's no other questions, I think we're going to wrap this up. I'm going to have to edit this before I post it because obviously I was talking away there thinking you guys could see my screen and you couldn't. So I'm probably going to have to go back and do a bit of editing. Sorry about that. I'm just not familiar with this tool. I tried using School because I got a special offer from the people who developed School, and I thought, okay, I'll give it a try. And it certainly beats the alternative is to build my own thing in Coda, and I could do it, but it's a lot of effort. But I have to say, I'm not impressed with their live video system. So I'll probably switch to using YouTube Live in future, where at least I know what I'm doing and I have better control over it. Thank you for your time. We still are within the 1.5 hours. JP, you disappeared on me there, so I don't know, did you have any other questions or are you happy to go?
No, yeah, sorry, I had on my side something breaking. I need to reconnect, but it's fine. And the simplicity, with all the respect, because the simpler a product is, the more work is behind it. So
Yes.
I need to show respect for that. But I
Well,
think,
yes, this is true. Yeah.
I think it has a good chance to be implemented even myself without any coding background. I'm really impressed also to see how in the beginning was shown creating the right formula. I wish I have known that earlier.
Okay. Well, what I have found is that if you switch to GPT-5 or any of the modern versions, the latest version of all the major models actually do understand CFL very well, and they understand how to build packs. So
Yes, yeah.
GPT-4, which is what is available by default in Coda, doesn't do it. But if you were to bring up GPT-5, and the other thing I get people to do is I get my managers, my clients, to go and do some knowledge-based training. So I don't know if you're familiar with Google Notebook.
Yes.
The Google Notebook LM is a great way to practice. So you load up your documents into the knowledge base, and then you can ask for summaries, you can get audio, video overviews, a mind map of the whole thing, and so on. But you can actually ask questions. And
Working
here's where I
amazing.
asked that question, and it is actually very good.
Yeah.
So Google Notebook, because it's using the latest, it's using GPT-5. And for some reason, GPT-5 has a much better understanding of Coda. But it won't have any understanding of your own business. So if you have a lot of proprietary knowledge and information in your own business, you have to load those documents into your sources for the Google Notebook LM. and practice, because one of the things you can do is when you give it a query is you can switch on and off different documents and see which ones are most useful in generating the results you're looking for and so on. So I always point people at the Google Notebook LM as a playground or a training ground for managing your uploading your documents and seeing how they work. Okay.
Good tip. Thank you.
Okay. Well then, gentlemen, I'm going to leave it at that for now. And the next workshop is on Thursday, and then it's once per week after that. I will be posting this video on the school website. And now that we're all back at work and I'm back on my office again, I'll be posting more stuff into the school forum as well, explaining the theory behind some of this stuff and some of the tricks. And Stefan, your question prompts me to bring forward my work on the precision AI tricks. I do have a video in my YouTube channel that includes precision AI as one of the videos. So if you go there and look at that, you'll see those tricks explained a bit better. But it needs updating. I think that's probably about a year old at this point, and a lot has changed in the last year. Very good. Happy New Year. Don't be good, just be careful, as I always say. And that's it for now. Thank you, and
Thank you
goodbye.
very much. Bye bye.